Okay, guys, so today's lesson is over what we call radicals. The radicals that you are used to are specifically square roots. So, for example, let's say we have something like x squared. Okay, squared is an exponent, right? Well, you can cancel out that x squared by using what we call the square root. And the square root is specifically a radical, right? Radicals are anything like square roots. So let's say you have something that's to the third power. Well, when that happens, you have what we call a cube root. So it looks like a square root, but you have that 3 in front. And you can use that for any power that you want. So you have what we call the radical, and whatever is inside the radical is what we call the radicand. So when I say radicals, I'm talking about these situations here. We're going to be focusing on this one right here. So we're going to be focusing on specifically square roots. But when I say radical, same thing. So just to kind of reminder over square roots, let's say you have something like the square root of 25. If I were to give you the square root of 25, most of you would be able to tell me that that's 5, right? Because 5 times 5 is 25. Well, 5 times 5 is a pair of numbers. And that's what we're actually doing when we're dealing with radicals. We're looking for pairs because it's to the second root. So pairs are 2. That's what's happening here. Um, One thing I do want to show you, and this isn't super important for you this year, it's just to kind of get you used to this new term. But sometimes you will see negative square roots. So let's say you have something like the square root of negative 49. When this happens, you get something called I. I is in a number set, and that number set is specifically called imaginary numbers. Now, when I say imaginary numbers, I'm not talking about like fairy tale land, right? Even though that's what it seems like. Basically, an imaginary number deals with something where you can't get a real solution. So we use what we call I for imaginary numbers. Basically, I is equal to the square root of negative 1. Because in a normal situation, let's say you have your calculator or whatnot, if you take the square root of negative 1, you're not going to get a number. It's going to say it's not possible. That's because it's imaginary. You won't have to use that, okay? It's just an introduction, something to know. What you will tell me, if you have a situation where it's a negative square root, you're going to tell me it's no real solution. So this would be your answer anytime you're given a negative square root. Okay. You'll do more with imaginaries when you get to Algebra 2. So what you're focusing on is if you have a negative square root, you know it's no real because it's imaginary. So that's kind of our first introduction into radicals. Now, here's where it becomes interesting. We know that 25, the square root of 25 is 5, because we know 5 times 5 is 25. Well, sometimes you'll have situations where you don't have what we call perfect squares. So let's say you have an example like the following. So you have the square root of 8. You cannot take the square root of 8 and get a integer, okay? Or a whole number, right? When you take the square root of 8, you actually get a decimal. It's like a super long decimal that goes on forever. So the square root of 8 is actually what we would call irrational. You're just going to get a decimal that goes on forever. But here's the idea behind how we could simplify this, because you can always simplify radicals. And the idea is if you look at 8, right away, you could probably decide the square root of 8 is the same thing as the square root of 2 times 4. Because 2 times 4 is specifically 8, right? You take 2 times 4, you get 8. Well, by the properties of square roots, you can actually break this up as the square root of 4 specifically times the square root of 2. That's just a property of square roots because that's the same thing as this up here. Well, we know the square root of 4 is equal to 2, right? 2 times 2 is 4. You can't do anything with that square root of 2, so you would leave it like this. So if you were to simplify the square root of 8, your answer would be what we call 2 radical 2, or 2 square root of 2. That is the easiest way to do it when you're dealing with numbers that are smaller. Like you can tell right away a perfect square that goes into that number. But sometimes you might not have that luxury. Sometimes you might be dealing with big numbers. So let's say, for example, you're dealing with something like the square root of 60. Now, right away, you probably can't tell a perfect number, a perfect square that could go into 60. So the easy way to go about this is bringing back up our factor trees. So you would find the prime factorization of 60. So if you remember, basically we take our prime numbers. So prime numbers are 2, 3, 5, 7, right? Those are all prime numbers, and you come up with your factor tree. So if I take 60 here, 60, I know 2 can go into 60 30 times, right? 2 is a prime number. 2 goes into 30 15 times, and then 15 breaks down to 3 and 5. So that would be the prime factorization of 60. So if I rewrite the square root with the prime factorization, so we've got 2 times 2 times 3 times 5. Here is your goal. Your goal is to find what we call pairs. So you want to circle any pairs that are given to you. Okay, those pairs you're going to be able to pull out, and I'll show you what I mean here in a second. So if we look here, we have a 2, a 2, a 3, and a 5. Well, we have a pair of 2s, so I'm going to circle those. What we can now do is we can pull out that pair of 2s. Now, when you pull it out, you're only taking out 1. Okay, so 2 times 2 is like 4, right? And we know the square root of 4 is 2. So we're only pulling out one of them. And then we still have our square root. And what's left in your square root is this 3 times 5. So now your last step is you want to multiply out that 3 times 5. So your final answer is actually 2 square root of 15. And that would be your simplified radical of the square root of 60. Hopefully this is making some sense. Let's do one more example, and then I want to show you a couple specific situations. So the next example that we're going to look at is the square root of 300. So the first thing we want to do is we want to break down this 300. So we've got 300. That's a big number. We want to break that puppy down. An easy one that I'm going to start with, I know these aren't prime factors, but it just breaks it down easier. I know this is 10 times 30, so now I'm going to break down the 10 and 30. I know 10 and 30 aren't prime, but it keeps us from getting bigger numbers. So 10 is the same thing as 2 and 5. Those are both prime. 30 is 2 and 15. 2 is prime. And then we got 3 and 5. So there's your prime numbers. So then if we rewrite the square root of 30 with our prime factorization, we have 2 2's, so 2 times 2 times 3 times 5 times 5. So that's the prime factorization. And again, we want pairs. So one pair, we have these 2's. In another pair, we have these 5's. So 2 times 2 is 4. Square root of 4 is 2, so we want to pull out a 2. Same here, 5 times 5 is 25. So square root of 25 is 5, so we want to pull out a 5. What we're doing is we're multiplying these. When we pull it out, we're multiplying because that's prime factorization, you're multiplying. And then left in our square root is that 3. That's all that's left in the square root. So the last thing you need to do is you need to multiply that 2 times 5, which is 10, square root of 3. And there's your answer. So if you wanted to simplify square root of 300, it'd be 10 square root of 3. Okay, now there are a couple of specific special situations that I want to show you, and that will be all. And actually clear this page. So here are the two special situations I want to show you. First one is what happens when I give you the square root of negative 64. So what will be the answer to this? Hopefully you see this and you remember, oh, I know this is kind of imaginary because it's got that negative square root. But for us, anytime right away you see that negative, you are telling me that this is no real solution. And that is your answer. No real solution. Okay? So your answer here, no real solution. The other one I want to look at is something like the square root of 16. Now, when you see this, you probably can tell me right away, all right, I know the square root of 16 is 4. That's fine. I want to show you how this works with the factor trees so you can really get an idea of why these factor trees work when you're finding pairs. So if we take 16 and we do the prime factorization, 16 is 2 times 8, so 2 is a prime number here. 8 is 2 times 4, 2 is a prime number. 4 is 2 times 2. We've got these prime numbers. So the square root of 16 with prime factorization is 2 times 2 times 2 times 2. And we have a pair of 2's here, a pair of 2's here. So we're pulling out a 2 times 2. There's nothing left in the radical because we have all pairs. 2 times 2 is 4. So as we know, square root of 16 is just 4. So when you're simplifying radicals, you want to take your factor tree, get your prime factorization, look for pairs. Any pairs you have, you pull outside of the square root. You are going to have a short canvas check to go along with this, so I can make sure you have a good idea and understand what's going on. Other than that, I hope you have a great day back from break, and I'll see you soon. Bye, guys.